We are starting with integration by parts, recursive functions. We'll take some examples. Integration of e raised to minus x sin x dx. Okay. So here, as we can see, exponential term is placed first and then the trigonometric term. So it is not as per the light rule. Okay. First trigonometric should come and then exponential should appear. So what we'll do is we'll interchange this, we'll reverse this. I is equal to sin x into e raised to minus x dx, and we'll make it equation number 1. So this is u and this is v. We'll use the formula u integration v dx minus bigger integration d by dx of u v dx bracket close dx. Okay. Now we'll put the values of u and v in this formula. Okay. So sin x e raised to minus x dx minus bigger integration d by dx of sin x integration of e raised to minus x dx bracket close dx. Okay, now we'll make a working note because again and again we can't just solve this integration of e raised to minus x. This integration of e raised to minus x, it's going to appear again and again. So e raised to minus x dx integration is equal to e raised to minus x upon d by dx of minus x as per the chain rule. So e raised to minus x upon minus 1, which is equal to minus e raised to minus x. Okay. So we have solved this separately. Integration of e raised to minus x is e raised to minus x. X is getting replaced with minus x. X is getting replaced with minus x. So derivative of minus x will come in the denominator. Minus x is a linear algebraic term. Okay. Derivative of minus x is minus 1. That minus is shifted in the numerator. So just remember, throughout the problem, whenever we see e raised to minus x integration, it is minus e raised to minus x. Okay. So this is equal to sin x integration of e raised to minus x is minus e raised to minus x minus bigger integration d by dx of sin x is cos x, and this is minus e raised to minus x dx. Okay. Integration of e raised to minus x integration of e raised to minus x take a look at the previous step if you want. I'll write this as minus sin x e raised to minus x minus sin x e raised to minus x, and as I said you, this minus and this minus multiplication, it will become plus integration of cos x e raised to minus x dx. Again, this is u and this is v. Apply the same formula, integration by parts formula. Okay. So we need not put a bracket over here because there is a plus sign. We can just apply the formula u integration of v dx minus bigger integration. Okay, I'll not get space over here. I'll just write it once again. So minus sin x e raised to minus x plus cos x e raised to minus x dx minus bigger integration d by dx of cos x e raised to minus x dx bracket close dx. Okay. So this is equal to minus sin x into e raised to minus x plus cos x. Derivative of e raised to minus x is minus e raised to minus x minus bigger integration. Derivative of cos x is minus sin x, and integration of e raised to minus x is e raised to minus x minus e raised to minus x. Okay, dx. Now just take a look at the next step, which I'm going to write. Okay, first of all, I'm going to write this term as the yellow colored term as minus cos x e raised to minus x, and at the same time, this blue colored minus into minus, I'll make it as plus. So just see what is happening. I is equal to sin x e raised to minus x, then this term minus cos x e raised to minus x, okay, minus this term sin x e raised to minus x dx, sin x e raised to minus x dx. Now this we can't solve once again by taking this as u and v. This is a recursive function. It will occur again and again. It will be a never ending thing. So this part will be replaced with I. If you take a look at equation number 1, I'll show you that. Okay. So it will be replaced with I. Fine. So this minus I you can transfer on the left hand side. It will become plus I. Sin x e raised to minus x minus cos x e raised to minus x. Okay. I plus I will give you 2i. 2i, take e raised to minus x common. Sin x minus cos x. Okay, then I is equal to e raised to minus x sin x minus cos x upon 2, and then you can just put plus c over here. 2 you just cross multiply and just put plus c at the end. Okay, so that was just an example of the recursive functions. We'll solve some more. So let us take one more example. I'll not be solving this entirely, but then I'll be giving certain hints. Okay, so the question is integration of cos of log x dx. Okay, now here we'll use method of substitution. Put log x is equal to t. Okay, so d by dx of log x is equal to d by dx of t. This will give us 1 upon x is equal to dt by dx, and dx is equal to x dt. Okay, dx is equal to x dt. Now our job is to eliminate this x, because whenever t comes into picture, x will not come into picture. Okay, so what we are going to do is, if log x is equal to t, we can write x is equal to e raised to t. Okay, we have a property in logarithms. If log a equal to b, therefore a is equal to e raised to b. Should remember this property. Okay, so if log a equal to b, a is equal to e raised to b. So if log x is equal to t, x is equal to e raised to t. I have applied that property. So here I will eliminate this x by writing as dx is equal to e raised to t dt. Dx is equal to e raised to t dt, right? Furthermore, what I'll do is I'll go back to equation number 1 and I'll write from 1 integration cos t, because log x is t, and dx is e raised to t dt. E raised to t dt, right? So this is trigonometric and then followed with exponential term. So it's the right order, u and v. So you can solve this problem using integration by parts further, and towards the very end you can substitute log x as t as log x, resubstitute t as log x. Okay, and obviously this one is a recursive function. This one is a recursive function which we have done earlier, right? Okay, so the question can also be asked in terms of integration of sine log x dx. So here also log x you can put it as t. Fine. Next example. Integration of e raised to 2x sin x into cos x dx. So what we'll do is we'll multiply and divide with 2 over here. We'll multiply and divide with 2. The reason being because there are two terms over here, sine as well as cos. So we multiplied and divided with 2. So 2 sin x cos x becomes sine 2x. Okay, and this 2 will take it outside the integration sign dx. Fine. So this is your exponential term and then trigonometric term. So you need to rearrange this. So we'll rearrange this in this manner: half sine 2x e raised to 2x dx. Take the first term as u, second term as v. Now why we rearranged? Because the trigonometric term has to appear prior to that of exponential term. So this is half. Then you have to solve the entire thing in this bracket, and this is a recursive function, right? Okay, next example. Integration of 1 upon x cube sine log x dx. So we'll rearrange the terms. We'll write sine log x, okay, into 1 upon x square into 1 upon x dx. Now we can put log x is equal to t. Why we are putting log x is equal to t is because its derivative is already present over here as 1 upon x, right? So let this be equation number 1. Okay, put log x is equal to t. So dy dx of log x is equal to dy dx of t. So 1 upon x is equal to dt by dx. Fine. So dx becomes 1 upon x dx will become dt. So from here 1 upon x dx can be written as dt. Fine. Also, when log x is equal to t, what will be x? X will be e raised to t. X will be e raised to t, right? So what I'm going to do is, after this step, log x is t, 1 upon x dx is dt, and this x, the one which I'm highlighting, this x is e raised to t. So from 1 integration of sine t 1 upon e raised to t the whole square dt. I repeat, log x is t, 1 upon x dx is dt. See, log x is t, 1 upon x dx is dt. Okay, but then what about this x? This x will be e raised to t. It is as per the logarithmic property. If log x is equal to t, x is equal to e raised to t. See, because when t comes into picture, x should not be there. So this can be written as sine t 1 upon e raised to 2t. Then by laws of indices, this is sine t e raised to 2t dt. Then you can solve using integration by parts on your own. Okay, using recursive functions. Fine. So I've given you the hint till here. Okay. One more example we'll consider over here. X square e raised to x cube cos x square cos x cube dx. Cos x cube dx. Okay. So we'll rearrange the terms. We'll write cos x cube e raised to x cube into x square dx. Now, as we know, the derivative of x cube is 3x square. So what I'm going to do is, I'm going to put this x cube as t. Okay. Put x cube is equal to t. D by dx of x cube, d by dx of t. So 3x square is equal to dt by dx. 3x square is equal to dt by dx. So x square dx is nothing but dt by 3. And why do I require x square dx? It is because of this. See x square dx. So x square dx becomes dt by 3. So x square dx will become dt by 3 and x cube will become t. Okay. So in the next step, what I'm going to do is, from 1, I is equal to cos t e raised to t dt by 3. X cube became t. So cos t e raised to t dt by 3. So I is equal to 1 by 3 cos t e raised to t. Cos t e raised to t. So this is u and this is v. It's in the right order, trigonometric and then exponential. So you're going to solve the entire integration by parts within this curly bracket. And it's a recursive function. Fine. So that's it with regards to integration by parts of recursive functions.